thank you all for logging in or registering for this webinar. I'm excited to present on this topic to you. It's a little bit different from what I normally do, but I feel like it is highly relevant to the work that my company does and our customers and consulting engineers that we frequently get to work with. And so I'm hopeful that this will be a great benefit to you and your teams wherever you are and whatever work you're doing. So thank you for participating and being involved in this discussion today. So without further ado, I would like to jump into it and get started. I will introduce myself. My name is Brandon Tremelling. I'm the Technical Resource Engineer for Geneva Pipe and Precast, which means that my job is all about being an industry resource for our industry of engineers, contractors, agencies. My company, we've been around for 68 years now, and we were recently acquired by Northwest Pipe Company. So we were part of a much bigger national presence that provides ample opportunities for us to learn and coordinate and collaborate on different challenges that affect our industry nationwide. So as I mentioned, we are part of a much larger group that provides ample opportunity for us to learn from each other. And our attendance today, the registrations we saw are from a pretty varied group. So some of the content that I'm going to cover today is more specific to Utah, where I'm based out of and where our Geneva pipe plants are located, those red dots you see on the map there. But if you have specific challenges somewhere else that may not be quite as relevant to Utah, please feel free to fill out that survey and we'll try to create content that might be more based on your local region. So our agenda for today, I want to start off by talking about the impact of infiltration and inflow on sanitary sewer collection systems, and really what that looks like in terms of impacts you can have on your local communities, as well as the impact of cost in mitigation or even reactive situations. Then I want to talk about all the different points of infiltration and inflow in a typical storm sewer or sanitary sewer manhole. And we'll go through different ways to either protect or rehabilitate/mitigate these problems at those access points. And in doing so, I'm hoping that this will allow you to take this information back to your communities and really help make an impact, both by bringing down operational costs and really improving the level of service for our communities. So to start off, the effects of sanitary sewer overflows, that's what SSO stands for, are many. We have all sorts of things that kind of go into this. We have infrastructure reliability. What is the impact of, let's say, a lift station being overwhelmed by influent water after a significant rain event? The public health and safety side of the sanitary sewer overflows into the environment, direct costs, which might be more the repair of overwhelmed infrastructure that has been damaged as a result of those overflows. And then indirect costs can be as simple as the downstream or long-term environmental impacts that will have to be mitigated in the future. So one example of this that I want to cover is the North Carolina sanitary sewer overflow situation of Wake County, North Carolina. Now that's the Raleigh region, if you're familiar with that area. But as of this year, May 2024, there were more than 30 SSOs so far that had totaled more than 300,000 gallons of raw sewage spilling into the environment. Now, previous years have seen more than 500,000 gallons on an annual basis. And when looking at the impacts of this, they were able to identify that specifically these rain events and the inflow and infiltration that they were seeing from these rain events were causing these SSOs based on when they were observing them. And it was pretty simple to track that, with such significant SSOs over time. But I thought it was interesting that the study that the case study for this particular area they had identified that climate change had a significant impact on this. And as I was preparing this webinar and this presentation, I found it quite fascinating to see that just this week this region had what is determined or what is referred to as a 1,000-year storm, which means that there's a 1 in 1,000 chance that a storm of that intensity and scale will happen in any given year. And it happened. And so it's just a perfect example of how these things can be pretty unpredictable, but there are methods and strategies that we can use to try to mitigate them. The next one that I want to talk about is the Carson sanitary sewer spill. This is in LA County, which is the most populated county in the entire country. This was an 8.5 million gallon spill that occurred when actually a pipe collapsed due to corrosion problems, which if you're interested in talking about the impact of corrosion on sanitary sewage collection systems, we have a full series of webinars where we kind of go into some of that stuff in depth. And I would invite you to check that out or reach out to us if you'd like the links to those. But in this case, some of the impacts were there was a sinkhole that formed and an overflow that was the result of that deterioration, that collapse, and that sinkhole. Now, what happened was this occurred right off the side of a highway off ramp, and 8.5 million gallons has to go somewhere, right? Well, in LA County, they're right next to the beach, and all of that water flowed down the streets, down, the different neighborhoods and things like that, and flowed directly into the ocean. There were 7 beaches that were closed, and along that flow path that this SSO took, there was all this contamination where they needed to wash the streets, the cars, even vegetation had to be replaced. And it kind of, I wanted to highlight this case study because it shows that there are sometimes impacts that we wouldn't really foresee. I don't think most people think about car washing as, an impact or a cost associated with an SSO, but absolutely it is a public health and safety concern and therefore must be handled as one. One of the interesting studies that came out recently from FEMA highlighted that as they go through all their different disaster response data and analyses, they've determined that on average, every $1 that is spent on proactive care is the equivalent of $6 of reactive care. So whether you've got an agency that's saying, I'd really like to have some of these proactive strategies, but we really can't afford it. In some cases, you can't afford not to have it because what happens when all of a sudden that 6 times higher cost comes as a result of one of these disasters? And I wanted to highlight this little calculation of specifically the cost of I&I on a standard sewer agency. So if we were to do a sample calculation of a single manhole that had a 10-gallon per minute leak. Now, if we figure out what that is over the course of a year, we determine that it's over 5.2 million gallons a year that is leaking into this collection system. If we were to say that the average treatment plant cost per 1,000 gallons is only $2, that means that that single leak has cost over $10,000 a year. And so as we start talking about, proactive, reactive care, if we're waiting to do some of these mitigation strategies on a leak that's already happening, realistically, you're already spending the money to just treat that water that's coming through. We might as well go ahead and implement some of these strategies. So getting to the common access points for inflow and infiltration. The first one is probably the one that most people think about. We've got a storm and there's the nearest entry point for the stormwater to enter into a manhole is typically the manhole ring and cover. This is the typical manholes you see in the street. If you're not familiar, this is what is visible at the finished grade in the roadway or off in the right of way. That is the first access point for inflow. The next is grade rings, which we'll kind of talk about all these components in depth and different ways to address inflow and infiltration at these access points. But the grade rings are typically only used just to adjust that manhole ring and cover up to the finished grade to get as close as we can to that finished surface so we don't have, big disruptions in our traffic patterns. The next one is the joints on our manhole. The fewer the joints we have, the fewer the access points we have. And as you'll see, some of these strategies we're going to talk about are actually work by reducing the overall quantity of access points in a manhole system. And by doing so, thereby we can reduce the amount of inflow and infiltration we're seeing. The next one I wanted to highlight is our pipe to manhole joints. There's various ways to do this, but even if we're going outside of our manhole, I also wanted to cover our pipe to pipe joints and discuss kind of the impact that that can have on a typical collection system. So let's go ahead and jump into it. So starting with our ringing covers, I wanted to start by bringing up an interesting little fact that I learned through the course of the development of this webinar. And what's interesting is I found that the origin of vented manhole covers come from the occurrence of exploding manholes. Back in the day when, mechanics and gas stations and various industries would pour their waste chemicals just directly into the storm system. And I found this very interesting photo, or I guess newspaper clipping from 1937, the Chicago Sunday Tribune, where a manhole exploded, flew 75 feet into the air to crash through a skylight and then fall and kill and injure a few people. And so these manhole vents were originally developed to allow some of the concentrated sewer gases to escape and ventilate and reduce that explosive potential, which is rather fascinating now because we have much better environmental policies and standards. And now there are different impacts to having vented or non-vented covers, which we'll get into right now. So ring-in covers themselves are rather interesting because there are thousands and thousands of designs, as each agency typically likes to have their own or their own design or their own preference for whatever reason. And some of them are simply because you want a pretty one like Round Rock, Texas, or you want something that's simple and effective like anywhere else. So the ones that I want to highlight today are specifically the A1180 ringing covers that are produced by D&L Supply Company. And I want to pause and just thank D&L Supply for their participation and assistance in developing and gathering some of this information for me to present to you. There are a number of companies that really assisted with the development of this webinar so we could have precise and useful information for you to use in your work. So thanks to D&L. The first one I want to talk about for the A1180 ring and cover is that there are various different cover options. And there are kind of good, better, best options for whatever you might be looking for. And some of the different variations on what the covers for this combined ring and cover system uses can include differences in the venting area, the lifting method, different patterns. If you need or you're worried about strength capacity, or even if you want to eliminate the potential of inflow and infiltration with a gasketed option, there are different cover options which you may not know about. You may think of an A1180 ring and cover as just what it is. It's a single set that is what it is, but actually there are a number of covers that are available. We'll talk about a few of those right now. So the first one is the 13 designation, and this one is the 12-hole vent cover, which is, as I mentioned, I'm based out of Utah, so this is the most sold option in Utah. It is readily available. It is very, very common, and some of the considerations, and I don't really want to say cons, but considerations when using this is that these 12 vent holes provide 7 square inches of open area for rainwater to flow in. And again, the benefit of having ventilation out, but it depends on, what your specific system needs are. And if you have a manhole that is for sure the entry point for significant influence to your system, you may determine that this specific cover is causing problems. So that's one, that's That's the most common cover used for the A1180 series in Utah. But one that's a little bit less used less frequently is the 11 sub. How do I say this? The designation of the 11 cover. And this is an open edge pry cover. It has no vent holes. And so the only venting area is that single pry cover, that pry hole that provides a single square inch of open area, as you can kind of see there on the edge. Just has that little notch for you to take your pry hook and hook that and pull that out. Very popular as well, and is a bit stronger than the 13 series because you don't have those holes, which can be fracture points or weak points in the strength of the lid. The next one that if we wanted to go a step further and try to prevent any infiltration from the ring and cover, we can use what is known as the closed pickhole cover or the subset designation of the 10 cover with the A1180 option. This has no venting area, and even though there is a small hole, or I guess we call it the pick hole, to remove the cover, it is actually fully closed and does not allow any ventilation or water to go in and out of this area. Now, if now, this comes with a gasketed option and a bolted option by itself. It can come without either of those. So if you just wanted a cover that just sat as the normal A1180s do without having a gasket or bolting it down, that is an option. But if you have a situation where you're seeing so much surging from stormwater or things like that, and you're seeing the ringing covers are experiencing uplift, so the covers are being displaced from water surging out of the manhole, you might want a bolted option. You also might want a gasketed option if you want to prevent any water exchange back and forth. Now, I will say these ones are not as readily available. There is typically a cost increase, and it requires a little bit more care to make sure that those pick holes don't fill with asphalt, for example, which would be a challenge to remove. But for the ring and covers, there are definitely options for how to, at the time of new construction, when determining a ring and cover that's going to be most suitable for your manhole, there are options that I wanted to make you aware of. But let's say that you have a ring and cover that's already in place and you want to do something to protect it against further you want to protect it now that it's been installed against inflow and infiltration problems. There's a few ways to do that. There's gaskets that can be applied to most standard sizes of rings and covers. There's sealants and lubricants, and there's plugs for the covers that have holes in them if it is determined later that that cover should not have any vent holes. And that is just going to be determined based on what your specific considerations and situations are. But jumping into it, I want to first talk about the sealant applications. The first one, or the one that I want to highlight, is called the Hercules Shutout Sealant, and that's produced by the company Odie, the common plumbing supply manufacturer. This was co-developed when the Truckee Sanitation District, located near Lake Tahoe, California, they determined that they were seeing significant increases in their sewer flow rates that were correlated directly with storm events that they were seeing. And so they started looking around for something they could do to their existing manhole ring and covers that would prevent from water from getting in, if at all possible. And they recognized that there were kind of more extreme situations, but they just wanted to see if they could come up with some simple, effective solution to provide a sealant that would close off the joint between the ring and cover and prevent water from just flowing around the cover. So they started testing and working together, and they created this Hercules shutout sealant, which creates a water barrier between the manhole ring and cover. Some initial studies have shown significant reductions in inflow. You can find this product on the Odie website, and you can read through some of those studies that are a little bit difficult to compare, I guess, because storm hydrology can be so unique to different regions and topographies and things like that. But you can take a look at that evidence and decide if that's something that would be effective and useful for your system. But the application is incredibly easy, very minimal surface preparation, and a rather simple approach to preventing this leaking into the sewer system. The next one that I want to talk about is the manhole lid gaskets that are manufactured by the company Cretex. These can be easily ordered based on pretty standard manhole ring and cover dimensions. There is a very simple sealant that is applied. The gasket is set with, again, pretty minimal surface preparation. And so one of the benefits of some of these methods is that if you have installed a run of pipe, let's say you put in a new trunk line or a new area of your system, and you're not sure yet where you're likely to see the most inflow problems, these methods allow you to go ahead and install your manholes and then retroactively go back after you've determined which are going to be the most um, problematic, I guess, for letting the stormwater into your system, and then apply these rather simple treatments to prevent that moving forward. So this one also helps with reducing sewer gas ventilation if that's something that you're looking to limit. But this is but a very simple approach to simply gasketing that. And finally, if you have a manhole ring and cover, such as the first one from DNL that I highlighted that has those 12 holes in it for the venting, but you've determined that those are a problem for your system, there are manhole lid plugs and various other products available that can be used to quite simply just plug these holes and provide protection to retroactively seal those up. But I want to point out that anytime that we are limiting the ventilation of gases out of a manhole, we are actually potentially causing problems. And I'm not talking specifically about explosive potential like back in the 1930s. But what I am talking about is when we are trapping the gases of a sewer collection system in the manhole, there are corrosive elements in those gases that, if left untreated, the manhole structure, a concrete manhole that is, can be attacked by those acids and will cause degradation, corrosion, deterioration of that structure. And so there are ways such as vent pipes that can be used that are not going to be really a risk for increasing infiltration and inflow, but can allow some of that ventilation to clear out some of those concentrated sewer gases and reduce the likelihood of seeing structural deterioration. So just want to throw that out there when we're talking about some of these ring and cover treatments. But to move on, I want to talk next about grade rings. Now, I think grade rings, in my experience, are some of the most common areas that we see this infiltration going into the manhole. This one is a rather extreme example. But I want to point out that because grade rings are used to adjust the ring and cover to final grade, sometimes we want to be really careful with the increments and we want to use smaller grade rings. But the thing is that the more grade rings that we use, we've created the more joints in our overall stack up of that manhole from base to ring and cover, meaning that there's more points of entry or access points for groundwater to seep into our system. So in some ways, we want to limit that. And there's a couple of ways that I want to go over with you right now. The first one is the whirligig system, which is a rather simple method for doing kind of an all-in-one grade ring collar for the manhole ring and cover. Now, if you're not familiar, the collar is it's very important for the manhole structure because it prevents the ring and cover from shifting. It helps hold it down. It helps provide a distribution of loads over it. And it also can help prevent any water from getting in, down, around the ring and cover and deteriorating or moving some of the sediment there to create weak points under the asphalt and deteriorate a road, for example. So the whirligig system essentially will cut a form for a concrete collar to the finished grade to the correct height. that the ring and cover can set on perfectly, and that will allow that ring and cover to match the slope of the road, and it will provide support all around that ring and cover. And what's important to this conversation is it reduces the number of access points or joints versus typical grade rings, because now it is all one single piece of concrete versus a stack of individual grade rings. So this is an interesting one that could be used for both new construction, or if you have a manhole that's you're starting to see the asphalt crack and deteriorate around an existing manhole, or you're seeing infiltration at the grade rings. This can also be used in a rehabilitation application. Next one that I want to highlight are our chimney sleeves. Now, these are the internal and external chimney sleeves manufactured by Cretex. You don't need both. It would be one or the other. But oftentimes in a rehabilitation situation, we only have access to the inside. So these are rather simple in their application. They are rubber bands, essentially, that are pressed against the grade rings and prevent water from even reaching the access points if you're talking about the external chimney sleeve. And if you're talking about the internal chimney sleeve, we're using compression rings to force that rubber against the grade rings and hold back any water pressure that has attempted to infiltrate between those access points. Now, these meet some of the industry accepted specifications for resilient connectors. If you're not familiar with that term, it's pretty specific what goes into what a resilient connector is. But in this case, these chimney sleeves meet those standards and specifications. And an interesting study produced by ASCE reported that these mechanical seals, which rely on the compression and tension in these bands around the rubber, will actually can be expected to last up to 3.5 times longer than some of the chemical sealing methods where you're painting on a type of sealant onto those grade rings. Some of these products come with extensive warranties, and I would invite you to reach out to some of these companies to determine the suitability in your specific project considerations or agencies, as well as the benefits of some of these warranties and things of that nature. The last one that I want to talk about is also produced by the company Cretex. These are the Cretex Pro rings, and I just generically called them the corrosion-resistant grade rings. The reason for that is because they are made of expanded polypropylene, which means they are incredibly lightweight. They've got a 100-year design life, and they are very, very corrosion resistant. Now, why do I really care about corrosion resistance right now when I'm talking about inflow and infiltration? Well, like I mentioned, some of these sewer gases can directly attack the grade rings and any exposed concrete, really. And that attack can cause those elements of the structure to deteriorate. And as they deteriorate, they may create weak points, and those access points may become easier for water to force its way in and cause problems. And you might see increased inflow and infiltration over the lifespan of that structure if we are allowing corrosion to play its role. So the manhole joints are the joints that connect, if you have a cone, the cone to a riser to the manhole base. And generally these are sealed with mastic or a butyl sealant, but some of the things to consider when using these sealants are that performance of that joint is going to be highly dependent upon the installation of that mastic. And as we're loading the mastic on that joint, the idea is that it is, first of all, sealing the joint. But second, it's allowing some of the load distribution and some of those micro variations in the joint of the manhole. So that way we're not point loading the concrete, we're not creating possible fracture points for the concrete, and we're essentially creating a cushion between the bell and spigot ends of these manhole joints. But if we have even a slight gap in that, that's not necessarily going to compromise the structure, but it could dramatically impact the inflow and infiltration resistance. So we've got a couple of rehab applications that we can talk about specifically for addressing the leaks in a manhole joint. And then we also have an option for if you've got a new installation going in where you know that this manhole is going to be deep and there's groundwater nearly to the surface and you can expect a lot of head. And we'll just go ahead and jump into that. So the first one that I want to talk about are mechanical seals. Now, these are very similar to the chimney seals that we just talked about. They're pretty similar, and they're designed for head pressures of up to 14 feet. Essentially, again, you've got a rubber seal that is going to sit over that joint, and you can. They come in different sizes, so depending on how much coverage you need for your specific joint, or let's say you have an offset joint, or for whatever reason your structure is a little bit out of round, or something like that. These seals, because of the multiple compression bands that are on them, can be tightened to different levels. So that way we're accommodating for some of those variations. This specific product here comes with an advertised 50-year warranty. So again, if this is something where you've got a manhole that you know is gushing water, spraying water, and you need something that is going to have kind of a heavy duty sealant on that joint, this is a possible option in contrast to some of the more typical chemical sealants or injection grouting or things like that that are more common, but in my experience, aren't always the best application. So we're talking about these mechanical seals. The next one is, let's say that you have a manhole that has experienced some structural degradation. Maybe there's significant cracking. I had an engineer reach out to me recently with a manhole that had a vertical crack in one of the risers running from joint to joint and was spraying water the entire way. And he said, "You got anything that can deal with this?" And I said, "Well, if you're looking to simply patch that crack, probably not. But I know of a product manufactured by Geneva Pipe and Precast that allows for a full sleeving of a structure that from the flow line of that manhole all the way to the top can seal up and remove some of these access points. So this is called the hybrid PVC manhole for rehab. And essentially what it does is it takes an existing manhole structure and sleeves the entire thing from the flow line to the grade rings, essentially, and provides a fully structural rehabilitation. The rehabilitation itself takes about 8 hours per manhole. It can be done in live flow conditions, which is almost unheard of for some of the rehabilitation methods that get down into the flow line, especially when you're comparing to some of the chemical sealants. But because we are removing some of these access points, because we are having a single sleeve up to 20 feet in height for these manholes, we are reducing all of the manhole joints entirely. And in addition, what happens between the sleeve and the existing structure is a high flow, high strength grout is poured, which will work its way into any of those cracks, existing joints, any access points, and seal those up in addition to the sleeve. So this one has a 50-year warranty against corrosion. And so if, again, you're talking about trapping sewer gases and potentially impacting your system in that way, this is an excellent option for that. Now, let's say you have a manhole that, again, you know is going to be, 20 feet down and you've got groundwater up to the surface, and even in the design phase that infiltration and inflow are going to be a major problem. The next one that I want to talk about is gasketed manhole joints. Now, I want to highlight this in the context of the perfect line manholes that are manufactured again by Geneva Pipe and Precast. The design of this manhole structure is that every joint is gasketed from the base all the way up to the grade rings. The joints are resistant of up to 30 feet of head pressure. And in addition to having the joint resistance for inflow and infiltration, they're also fully lined with corrosion resistant materials such as fiberglass reinforced polymer for custom shapes and configurations of manhole bases, as well as cones, or if there are any specific features, like we've got a lift station where we need pipe inlets and outlets for, or mounts for, let's say, a pump or any sort of monitoring equipment, things like that, that can be fully accommodated And because all of the joints and access points are either welded shut or are gasketed, it prevents any future leaks from occurring, worsening, and also the non-venting strategies will not affect the structure performance. This method also comes with a 50-year warranty against corrosion, just like the sleeving option does. And this structure comes with a 100-year lifespan. Just to give you kind of a snapshot of what the joint looks like, we've got this gasket that rolls down over the entire spigot, seals directly against these corrosion-resistant liners, and provides excellent joint resistance against infiltration and inflow. To give a full stack up of what that product looks like and some of the benefits. Again, we've covered some of these things pretty in depth in some of our other webinars, so please feel free to reach out or yeah, look us up and you can probably find those. But the last one, because I want to hurry and get through this, that I want to talk about are the pipe to manhole joints. Now, typically rubber boots are used in a sanitary sewer collection system, but we still see grouted manhole to pipe connections. And I want to talk about one new approach to pipe to manhole connections as well. Now, rubber boots are pretty widely industry accepted, and the only installation problems that I wanted to just highlight for possible causes for I&I are misalignments of that boot, over or under tightening these compression rings, and improper surface preparation. So, for example, if there's a little piece of gravel or something that is going to affect how that boot sits, it can create very easily an access point for groundwater to flow in. Finally, grouting. This is one where typically if you have a concrete pipe coming to a concrete manhole, that's most typically where we're seeing a pipe getting grouted in. But you just need to be really careful that that pipe is well supported before this stage, because if not, the weight of itself and any possible construction loads over top can crack that pipe. And so just need to be very careful that the pipe is centered, is not going to be moved, is very secured and protected against overloading. Final one I want to talk about here is the cast-in pipe connectors in manhole bases. Now, this is a rather new technology where in this case, in these photos, these connectors are used with a liner that is then cast into the concrete. So when a manhole base is delivered on site, you already have this pipe to manhole connector that is cast into the concrete, has an integrated gasket, and the way that it's designed, a pipe coming into the manhole will match the flow line of the base based on the positioning of that connector. And again, just like just like what we talked earlier with the boots being kind of flexible and able to accommodate slight variations in the field, so can these connectors with the gaskets accommodate various deflections in the field and can be manufactured to accommodate significant slopes coming into or out of a manhole. But these perform excellent protection against inflow and infiltration. And again, I apologize. I'm going to have to start going quickly because I over-prepared for this webinar, I think. So I'm actually going to skip this quiz right here just to keep going. But I finally want to get to our pipe-to-pipe joints. The pipe-to-pipe joints generally perform really well, especially when we're using PVC pipe that's gasketed. Generally, the joints perform pretty well, but there are a few considerations that can impact how that joint performs. One of them is debris in the joint, just like I mentioned with the boots. If there's any gravel or something like that, that's going to affect how that pipe fits together. That's a very easy access point for any pressure in the groundwater to just force its way in. Over lubricating can sometimes cause a gasket to roll. Under lubricating can tear a gasket. And finally, angled insertion of a pipe can either crack it or can cause the gasket to fail. Finally, improper backfill and compaction definitely play a role because some pipes are more heavily reliant on proper bedding and backfill practices. So if it's not done well, pipes that aren't inherently structural themselves can quite easily get out of round, can crack and break, and again, create access points. So one of the one of the kind of optimal ways to address the pipe joints is having an all-in-one option. Now, what I wanted to highlight here is a newer product that is designed to handle loading just as concrete pipe does, but it also offers exceptional resistance to inflow and infiltration. And finally, resists the degradation that occurs from some of these sewer gases that may build up if we're using the non-venting mitigation strategies. So the way that we can do this is by using a lined pipe that is rigid in nature, not a flexible pipe. So rigid being concrete pipe, um, and then using the HDPE liner that provides the corrosion resistance. Now, for large pipes, what we can do is we can weld these HDPE liners together and fully eliminating the access point of these pipe joints. So that is one method to eliminate those access points altogether and provide incredible structure as well as corrosion resistance. But those typically are only feasible for very large pipe diameters. So for small pipe diameters, what we can do is we have what we refer to as our perfect pipe, where all the pipe joints has, as you can see here, these black bands that we refer to as our couplers. These couplers have gaskets on both the upstream and downstream side. So these joints are double gasketed, fully protecting against infiltration and inflow. This is a photo of what our perfect pipe looks like. And the components are our typical concrete pipe. Could be made to any class, any specific loading considerations that we need. Generally, standard concrete pipe diameter starting with 24 inches. But they have these black couplers that have two gaskets, and the HDPE liner inside is covered in these anchors on the backside. That when we cast it into concrete, it locks that liner in place and prevents any possible delamination from occurring. The way that we manufacture this is we weld the liners together. We spark test every single liner, every single weld. The liner is then expanded, so that way in that photo on the right, you can see there's an internal bell where that coupler will sit, so the flow line is not impacted in any way. We then slide that over our forms, we pour our concrete, we allow it to cure, and we strip it. And that's essentially our perfect pipe. Some of the benefits of this pipe-to-pipe joint is that we have tested for infiltration and exfiltration resistance. It's been tested up to 50 psi for its ultimate capacity. We tested it at 36 psi working capacity for 20 hours. And let's be honest, that is a lot of pressure. If we're talking about head in groundwater, that is excellent resistance to I&I. And I'm not even going to go over exfiltration because that's not really what we're talking about. But we have tested it up to 60 psi and it performs very, very well. I want to cover really quickly the strength of the liner. We've tested that as well. And again, the delamination potential of the HDPE is virtually non-existent. And the concrete, in some applications, the HDPE liner is stronger than concrete in tension. So it's an excellent product when we're talking about durability, corrosion resistance, and joint and I&I resistance. Here's some of the benefits, and I want to spend the last little bit talking specifically about a case study where this perfect pipe was used, and that would be the 950 North Sewer Trunk Line in the Central Davis Sewer District here in Utah. Now, the project considerations of this project were that there was 3,400 linear feet of sewer pipe, 12 manholes. It was bid with various pipe materials, but the district decided to go with perfect pipe for a couple of reasons. There was exceptionally deep installation, groundwater was nearly to the surface, and there was going to be a major highway constructed directly over this pipe. So they needed all those things. They needed the durability and strength of concrete pipe, something that wasn't going to deflect or be entirely reliant on the installation practices. They needed something that was going to resist the groundwater pressure trying to force its way into the pipe. And because the there was going to be a major highway constructed over, they wanted to make sure that there weren't going to be any corrosion problems in the future, and so determined that they wanted to be proactive in protecting this pipeline against possible corrosion and deterioration there. So that was one that was fun to do here in Utah. Another one that was interesting to highlight was that the 1800 North crossing in Logan, Utah, where we manufactured jacking pipe with HDPE liner. So they didn't need a casing pipe and then a carrier pipe, as typically is done in micro tunneling applications, but they had a kind of an all-in-one lined jacking pipe that allowed for direct flow, called a one-pass solution for this application. This one was only over 100 feet that connected to two manholes, but went right under a railroad, which normally would have required a casing and carrier pipe. So that is kind of a benefit of the pipe-to-pipe connection application of this specific product. And now that we're about out of time, I just want to go back and say, again, my name is Brandon Tremelling. I'm the technical resource engineer for Geneva Pipe and Precast, which means that my entire job is about being an industry resource for engineers, agencies, contractors to provide training and to do events just like this, where if you ever have a question or your team ever encounters a situation where you could use someone with direct precast infrastructure experience, please feel free to reach out, because again, that's my whole job, is to help you do what you do every day. And now I'd like to see if we have any questions in the Q&A. Been a little busy giving the webinar to kind of keep track of that this whole time. But while we go through that, I've got my contact information here showing. Please feel free to reach out anytime. You can add me on LinkedIn if you'd like. We've got some cool upcoming conferences I'm going to be presenting at, and I'd love to meet you in person if you happen to be attending any of those, such as WEFTech in a few weeks. I'll be presenting on one of our other product lines there. But let me go ahead and pull up our Q&A. So the first one that I see here is, does the Hercules sealant need to be reapplied when the manhole lid is removed, or is it permanent? For my research, it is not permanent, but it performs, again, the reports and available data showed significant reductions in inflow around the manhole cover, between the ring and cover. And they did say that reapplication is necessary, but because that's going to be so unique to different climates, to different types of rain events, things like that, they specifically said, like, you're going to need to observe for the first, period of use to identify what is going to make the most sense in your system. Because I can tell you right now that with some of the components of the sealant, an area such as Arizona that gets very hot and very dry is going to react very differently than, let's say, Minnesota. That's going to be maybe colder and wetter. And so there's a little bit of petroleum-based products, I believe, in that mixture. And so I'll let you do some of your own research on that. Okay, another question we had was, what type of remediation is recommended for new pipe connecting to an existing manhole at the manhole gasketed joint? So that's an excellent question. Typically, we would use a boot connector. Those perform pretty well, with a torque wrench being able to compress to a properly cored hole in a manhole base, as long as that surface is going to be continuous, smooth, and is going to adhere properly to the compression of that boot. We just want to make sure that there aren't so many surface variations that are to an extent that it would affect how that boot is going to sit against that cord section. So that is typically the method that we would use. It says, does the Hercules shutout sealant dry hard, or is it a rubber? It does not dry hard. I believe it stays as a lubricant, and actually some of the installation considerations say you need to do some minimal surface prep. You just kind of need to brush off that area, wipe it very briefly. You'll apply the sealant, and then with a wet finger or rag, much as you would with silicone on like a DIY project, you would run your finger around and ensure that you are essentially smearing that sealant around the edge. Once that sits, though, because of the adhesive properties of the sealant and the minimal dimension between that cover and the ring. That sealant is essentially just going to act as a plug on that tiny little crevice that performs very well. With that, I just want to thank you all for your participation and attendance today. I really do enjoy these opportunities to speak to our industry and hopefully bring some solutions to you that you weren't aware of or were at least familiar with yet. But again, please do feel free to reach out if you ever have any questions regarding anything that I presented on. And even if I don't have the answers, I'm happy to connect you with the people that do. So again, thanks for your time, and we will look forward to having you back at our next webinar in this series. So have a good day, everyone.